Good day. Let us use the next two examples to demonstrate how to find equation of straight lines. Let us recall that gradient of a line is essentially the change in y over the change in x. Now, if we look at the diagram on page 98 of your notes, on this diagram, we have 3 points PAQ lying on a straight line. We can also say that PAQ are collinear to each other. Knowing that it is collinear, we know that the gradient of PA is equals to the gradient of PQ. And if I were to write down how to find gradient of PA, essentially is y minus y1 over x minus x1. If I want to find the gradient of PQ, from the diagram, we know that it is y1 minus y2 over x1 minus x2. Let's do some manipulation. If I were to multiply both sides by x minus x1, so when this side, gradient of PA, is multiplied by x minus x1, we know that it is left with y minus y1. For this right-hand side of the equation, if I were to multiply by x minus x1, this expression is what you will get. Now, we also know that the gradient of a straight line can be obtained from y1 minus y2 divided by x1 minus x2. We will then therefore be able to conclude that this fraction here essentially is the gradient. My point, the straight line can actually be expressed not just in y equals to mx plus c, but it can also be expressed as y minus y1 equals to m times x minus x1. Perhaps too much algebra? Let's use the next two examples to demonstrate. Let's now turn to page 99 of your notes. With this first example, the diagram, which is not drawn to scale, shows two lines AB and CD, in which CE is equals to ED. And also given is the angle AED at 90 degrees. AED at 90 degrees. So we are saying that this is perpendicular to this. The coordinates of C and D are 0, -2, and 5, 5 respectively, also indicated in the diagram. Find the coordinates of E. Now, if we know that AB cuts CD into two equal halves, all right, we can then therefore say that the point E is actually the midpoint of CD. Recall, midpoint formula, we therefore have E essentially is 5 plus 0 over 2, that's the x-coordinate, and then 5 plus -2 over 2. Hence, the coordinates of E is 5 over 2, 3 over 2. Knowing the point E, we see that the point E sits on CD. We also see the point E sits on AB. Question wants you to find, hence, find the equation of AB. So now you're asked to find the equation of AB. To find the equation of AB, we need to know a point on AB, which happens to be E. We also need to know the gradient of AB. To calculate the gradient of AB, we know that the line AB is actually perpendicular to CD. So if I were to first find out gradient of CD, all right, the gradient of CD is 5 minus -2 over 5 minus 0 to give you 7 over 5. Therefore, if I want to find the gradient of AB, it is as good as -1 over 7 over 5, which is the same as -5 over 7. That's the gradient of AB. Now, since we have the gradient of AB, we also know that the line, or rather the point E, sits on that line AB. So I'm going to use these values with E at 5, 2, x coordinate 5, 2, and then y coordinate is 3, 2, and gradient at -5 over 7. I know that the generic equation can be used to solve this. So I have y minus 1.5 is equals to the gradient x, the gradient and then x minus the x value. So y minus 3 over 2 is equal to negative 5 over 7x plus 25 over 14. So that gives me y equals to negative 5 over 7x plus 23 over 7, which is the same as 7. Y equals to negative 5x plus 23. There you go, the equation of AB. Let us move on to the next question. In the next question, A is a point 25, and the line joining the points AB has a gradient of 1/3. Right? You have a straight line, right? And then the point A is 2/5. The gradient of that line AB is actually 1/3. So if I were to sketch this, essentially this is point A, this is point B. I have 2, 5. I know the gradient of this line is a positive slope of 1/3. The perpendicular bisector of AB. So if I have a perpendicular bisector here, all right, if I tell you this is perpendicular, passes through the point 49. So it could be somewhere, say here. All right, 49. Note, the question didn't say that the line AB and the perpendicular bisector intersect at 49. It says that the perpendicular bisector actually passes through 49. So you cannot assume that there is a midpoint 49 and then, close shop. All right, first and foremost, the question wants you to find the equation of AB. To find the equation, you will need a gradient as well as a point. All right, it has always been the case, a gradient and a point. So now I know that the gradient is 1/3. Right, gradient is 1/3, and I do have indeed the point A coordinates. So if I were to put this in, I know that equation of AB is as good as y minus 5 is equals to gradient x minus 2. This will give me y equals to 1/3 x minus 2/3 plus 5. And that's it. It's 1/3 x plus 13 over 3, or 3y equals to x plus 13. There you go. Equation of AB. Knowing equation of AB, in part B, we ask for the coordinates of B. Now note that there is a line segment AB. The perpendicular bisector essentially is a midpoint, right? So with AB, I know the value of A, but I do not know the value of B, the coordinates of B, which is what I'm asked to find. So let's go see what we have thus far. Now, maybe let me figure out a point that sits on this line. So if I may, I would like to call this red point here, say M. All right, because I know that there is a M. The M is on AB. The M is also on the perpendicular bisector, of which I do have the equation of AB. Now, if I have this, let's see what I can get from them then. So if I let, say, x, y be M's coordinates, I will know that the gradient, if I talk about gradient of AB, I have 5 minus y over 2 minus x. This is actually 1/3. Simplify this, I get 15 minus 3y equals to 2 minus x. I can therefore say that x is as good as 3y minus 13. Right, this is my first equation. What else will give me the m then? What will give me the m? Let us take a look. If I have the equation of AB already, and I know that my M sits on AB and is the midpoint of AB, And if M sits on the perpendicular bisector, why not let's find the equation of the perpendicular bisector, and then we can actually fill in the point. So now if I talk about the equation of perpendicular bisector, I will know that the gradient of the equation of the perpendicular bisector is actually -3. Because if gradient of AB is 1/3, okay, gradient of AB is 1/3, therefore gradient of perpendicular bisector will then be -1 over 1/3, which is equal to -3. With this in mind, I know with the 0.49 and gradient equals to -3, I know that y minus 9 is equals to -3 x minus 4. Okay, y minus 9 is equals to -3x plus 12. Y is equals to -3x plus 21. So now I have two equations. The first equation is from the AB line. Second equation is from the perpendicular bisector. If I solve them by subbing 1 into 2, I will then therefore get y equals to -3, 3y minus 13 plus 21. So y is equals to -9. Y minus 3 times 13 is 39 plus 21. -3 times -13, so it's positive. Yeah. So I get my, oops, not y anymore. I think we can do something faster than this. I have 10y, right, is equals to 50. So y is equals to 5. With y equals to 5, no, y is equals to 6, not 5. Sorry. This is 60. 39 plus 50. 39 plus 21 is 60. Therefore, y is equals to 6. With y equals to 6, x therefore is equals to 3 times 6 minus 13. So that gives me 5. So I know m is 5, 6. And if I know m is 5, 6, m is the midpoint. So I will then therefore, if I let b be a, maybe be say p and q, I know that 5, 6 is equals to p plus 2 over 2, q plus 5 over 2. So I draw my conclusion. 5 is as good as p plus 2 over 2. So p is 10 minus 2, 8. Draw my conclusion. 6 is equals to q plus 5 over 2. Q is as good as 6 times 2, 12. 12 minus 5, 7. Therefore, B is 8, 7. Okay, so with our newfound formula of equation of straight line, I think it makes solving even easier. And also at a glance, as long as you have a point and the gradient, you can actually find the equation of a straight line. See you.